All right, let's keep going on this. I just like to kind of break it up into smaller segments. Now, so for this number 8, it got me when I first did it because it says which one is not true. And so, I just skimmed past that and I was like, well, that one's true and that one's true. And then the answers jived down here. So let's take a look at what else going on here and make sure we understand these things. So, first of all, this first question, it's what's true about the chi-square test of independence. And it says, the test is based on bivariate categorical data. So remember, bi is 2. So this is saying 2 variables, and we've talked about how they are categorical, not quantitative. Okay, so categorical. So that's true because if you remember our chi-square test of independence, you take one big sample and then you sort them according to 2 traits, and so you put them in those 2, you sort them according to those 2 variables. Okay, so that was true. Now, number 2 says the degrees of freedom is calculated k minus 1, where k is the number of categories. And so that's categories minus 1. Well, that is the degrees of freedom for chi-squared goodness of fit, because that's just one dimension of observed data, one that you put in list 1, okay? Chi-squared test of independence, that's multidimensional. So we've got rows minus 1 and columns minus 1. So that's what makes that one not true. Now let's take a look at this third one. The test is an upper-tailed test. And that's true because if you remember the shape of our chi-squared test, remember this would be a chi-squared value of 0. Okay, and then out here, the chi-squared value or the p-value is always this area to the right of that chi-squared test statistic. So because of the right skew of the chi-squared, they're all upper-tailed. So that one's true also. So therefore, the one that is not true is 2 only. All right, number 9. Okay, so this is a random sample of theater customers. So to me, when I read that and I glance back at this, that's one sample. One sample, and then they're going to take this group of people and then sort them and say, okay, what movie and what snack? So they're going to sort them by type of movie and type of snack. That's 2 variables. That's bivariate. That's your independence. Chi-squared test for independence. All right. Here we have this one. You have got to be able to do this. I mean, hands down, there's, if you have all the data given to you, which in this case, it was using this data here. So if you have this, then you can go put it into the chi-squared. You can go do the chi-squared test statistic after putting them into matrix. So that's what I'm showing here is I went and I put all the stuff into the matrix and then I ran the test. But I will be giving you a problem where you do not have the data to put into the matrix. Now you will be told the degrees of freedom. So I'll tell you the degrees of freedom, and then you'll get a chi-squared test statistic. Then you've got to figure out the p-value from that. So, here's our curve. So if I give you that chi-squared statistic, you need to chi-squared CDF that out here to go to get that p-value. So 5.66 to 999, remember 99 is not enough, with 2 degrees of freedom. So there is our 0.059, greater p-values in between 0.05 and 0.10. All right, next. Okay, so here is our free response. So here what we're dealing with is our killer bee stings and then the color that is being worn. So we actually have been told a rate of distribution for the colors. So at that point, I already am saying in my mind, oh, if they're telling me a rate, if they're wanting to know, has that rate changed? I'm thinking I got a claimed rate. That's got to be goodness of fit. So I'm looking to see if all I have is just one example, and then I'm looking to see for that claimed rate. Okay, but this first question is a little different. It says, in a random sample of 200 killer bees, how many would you expect to be agitated by color? So I listed each one out. Now, remember, if we were to do conditions, then our expected need to be greater than or equal to 5. Okay, so here green was 75%. So 75% of 200 is that. And blue was 9%. Of 200 is 18. And pink and purple, 6% of 200 is 12. And the 10% of 200 is the other 20. But, and this got me. I just kind of like went through the motions and going, bam, I'm just going to do this off of 200. And so I kind of went down here and I was like, oh, this is going to be the same thing. It's not. It's not, because this part B is done with a sample of 120. So watch out for that. Now, this null hypothesis would be that the killer bee stings are distributed as expected by the colors worn. And then the HA, the killer bee stings, are not distributed as expected by the colors worn. So is the color distribution different? Now, so let's do our conditions, our assumptions. Random, we have it stated that there was 120 randomly selected people stung by killer bees last year. Independent, 120 is less than 10%. So remember, if we have random selection, then we're going to do the 10% condition. So 120 is less than 10% of all such people stung by killer bees. Okay, and then I don't know if you really need, I'm getting confused on that. I don't think you need this independent thing because it's not more than one population. So see, Ms. McClellan needs to get that straight. I believe we only need this like stating that each color is independent or whatever if we had more than one sample from different populations, So if I have multiple populations samples, so I really don't think this is needed, okay? If we had a sample of boys versus a sample of girls and we were dealing with gender, then we might do that there. Large enough. We have to say the expected counts are greater than or equal to 5 in order for that chi-squared model to apply. So I showed all of those values, and look, that pink and purple one is barely big enough. 6% of 120 was 7.2. The name of this is a chi-squared goodness of fit test. And here is just a reminder that for these, you just have one dimension of observed. So this L1 is our observed, one dimension of the observed. So we do list, not matrix. And then here were those expected. I ran the chi-squared goodness of fit, and I got a chi-squared test statistic of 12.09 with a p-value of 0.0071. Degrees of freedom for goodness of fit, categories -1. So 4 minus 1 is 3. P-value 0.00 is less than alpha. So I reject HO. So there is evidence to suggest that the distribution of killer bee stings by color is different than previously stated or expected. Okay, so it may have changed. I need to go investigate that and see what they're stating about the color distribution. All right, and our number 12. So this is a problem where they say, okay, we are going to take a random sample and then of the orders placed during last year, and we're going to look at that one sample, and we're going to pull out a ticket and say, okay, what was your method of payment and what type of service was that? So I'm going to categorize this ticket by 2 variables, 2 traits, the method and the type of ticket. So that is 2 variables with 1 sample chi-squared test of independence. Okay? So because 1 sample is taken and the subjects are sorted by 2 variables. testing to see if there is an association between those two variables, which takes us to our null hypothesis. There is no association between the type of service and method of payment. And HA, there is something happening. There is an association between type of service and method of payment. All right, conditions. Random, we just have one sample to deal with here. It's stated that it was 400 orders. Independent, it was a random selection, so I will do my 10% condition. 400 is less than 10% of all such orders. And the large enough, showing that all the expected counts are greater than or equal to 5. So I actually went, because a chi-squared test of independence has multiple dimensions of data. So I use a matrix instead of list. Multiple dimensions of observed data. So I put my observed into matrix A. I go run the chi-squared test, not chi-squared goodness of fit, and there's what I get. So this p-value is very small because it's 1.76 times 10 to the negative fourth. Okay, and so there it is with 2 degrees of freedom. So then I went and I just screenshotted the expected matrix B because that's where those were put. So my p-value is low. I'm going to reject HO. There is evidence to suggest that there is an association between the method of payment and the type of service. So there's some kind of relationship. Now, if they had asked further information, so don't forget to be aware of this. With this type of a situation where they say, yeah, there is evidence of an association, then they might be asked, don't forget, if they ask for further information, then they were probably going to want you to look at each individual section. And so then you're going to want to do your standardized residuals. Okay, and I don't have that on here, but that's when you would make another matrix and you would do each cell's observed minus expected over the square root of expected. And when you get that observed matrix, that other matrix, if you have negative residuals, then what happened, what actually occurred was below what was expected. If you have a positive standardized residual, then what you observed was above what was expected. And so you're going to make a statement. Probably they would ask you something like, which contributed most to the chi-squared value. Okay? Alrighty then. That's it for those problems. I'll do another video on the AP Tester Trio and that little summary page that you have in the back of your packet.